There's a question about should we create a new project? You'd probably get away with just having a single project for the whole class. So I'd recommend that option. But I do think it's good if you're doing different data analyses that are going to have different data overall for various research projects to probably have a different project for each of those. All right, I think I'm going to go ahead and get started. So today we're on day 3, and we're going to be talking about subsetting data. Just a reminder, we haven't had any problems with this, but in general, we like to update everything the day of, even because we're listening to your feedback in the surveys and we're always adjusting our materials. So if there's ever anything that, people have confusion about, that's something to add to the survey so that we can go back over anything. And we like to recap or remind you about some of the things that we've previously discussed. So remember that we use this assignment arrow to assign our objects in R, the things that we can use and work on in R. And so I kind of think of it as pointing to something. And then we have this combine function that helps us put things together. And that's our C. That's how we make our vectors. So we might do something like this, and that'll show up in our environment. We talked about length and class. The length gives us the length of an object. Class gives us the type of object that it is, and str gives us some structure information. We talked about sequence for creating vectors with numeric values, and the repeat function for repeating values within a vector. And we talked about some reproducibility practices and how it can help make everything easier. And then finally, we talked about the read_CSV or read to lim from the readr package that helps us input data into R. Okay, but today we're switching gears a little bit. We're going to talk about how we can take a look at our data. It's one of the most important first steps to do with our data is examine it and take a look inside. And then we're going to talk about what a data frame is and what a tibble is. We're going to talk about how to create new variables, make row names from a column, rename columns, subset rows, subset columns, add or remove columns, order columns, and order rows. So lots of data transformations today. This is largely going to involve a really important package called dplyr. That's part of the tidyverse. So in this course, we're largely focusing on the tidyverse packages. The reason for that is they're just a really intuitive set of packages specifically designed for data analysis. So we really, really like them. There's more information on dplyr if you want to do more after this. Why is it called dplyr? Well, the D stands for data frame. So we're switching gears now from these vectors, which are just like a one-dimensional object where we have a long, string of numbers or characters, to something that looks like a table and that has rows and columns. And so that's typically what we're going to use for a lot of our data analyses. And so dplyr can be really, really helpful. And the idea here is that it's supposed to evoke plyers. That's what the plyr is for. And so it's allowing us to transform our data. When we load the tidyverse, it's going to load the dplyr package. So when we load the tidyverse using library tidyverse, and you know what? I'm going to do that over here because probably need it. If I have the commented version, it's going to tell me that it's attaching all these different packages, and then it's going to tell me things about dplyr. All these conflicts are saying is just that it has functions that have names that are similar to things in base R. And so it's going to prioritize dplyr now. So don't worry too much about that. All right. So first we need some data to work with. We're going to be working with some data that we're going to call ER. And it's about heat-related ER visits from 2011 to 2022 from the state of Colorado. So this was made publicly available by the Colorado Environmental Public Health Tracking Program. And if you want to find out more information, you can go to this website. But it's conveniently on our website. So we can load in the data using the methods that we learned yesterday. So we have this nice URL here, and we're going to use the read_CSV function. We're, of course, going to need quotes around that URL, and we're going to need to close our parentheses. All right, I get some information here. It loaded in a bunch of stuff. Got lots of rows, 6 columns. My delimiter was a comma. All right, so the first thing we want to do is like kind of investigate in a big picture way information about our data. So one of the most important things is looking at the dimensions. We could look in our environment. Sometimes it's hard to know what's being listed first, columns or rows. And that's true also for the dimension function. So here, this is going to give me my rows first and my columns. But if I just want to know one at a time, I could do n row and col as well. So I see that I have 6 columns and 768 rows. We've talked a little bit about the head function and the tail function. Head automatically gives us 6 of the top rows, and tail gives us the 6 bottom rows. And that's been pretty useful. And it can be useful for data sets that don't have too many columns. And notice this one doesn't have very many, so it conveniently fits everything on here. We can see that we have county information, rates of ER hospital visits, information about the 95% confidence interval, lower and upper, and visits, etc. There's a really nice function called glimpse that can help us to see the data a little bit differently. And it's going to rotate the data. So basically, it's taking all of our columns here and rotating it sideways so that they're listed here. And we're getting to see a preview of what some of the values are for each of these columns. And we also get that dimension information. This is a super valuable function because sometimes we have a ton of columns and we can't see them when we use this head function very well. We have to like scroll across when we have a really large data set like that. Another really helpful function is the slice sample function. And this can help us to take a look at just a random set of rows within our data. This is useful because sometimes the top of our data set will look a little bit different than some of the rest of our data. It's not uncommon, for example, to have a lot of NA values for early parts of our data where we might have had a lot of missing data, where maybe data collection hadn't really started in every place or something. So in this case, it can be useful to use this slice sample function. So it's going to take, like our sample function, a random subset, a random slice out of our data. So it's kind of like head, but it's just random rows in our data. So here we're taking the ER data and we're asking for 2 random rows. And because this is one of those random functions, if we don't set the seed, we're going to get different values each time. So let's see what that looks like. So I got yet another different set of rows here. In this case, I have some 0 values and some year information for a couple of counties. Notice that my counties are different every time, but just a reminder, if I set my seed and I do this more than once, I'm going to get the same information twice. All right. Moving on to this concept of these data frames and what's called a tibble. So a data frame is a really classic type of object in R. You'll see a lot of these. This is sort of the older form of a table. One example is the mtcars data set that comes in the installation of R. So if I type in mtcars, I don't have to do anything. It automatically shows up. I'll see this data frame show up. And if I ask for the class information, we'll see that it's a data frame. So I have all this information about various aspects of different cars, like their miles per gallon, the number of cylinders, different names of cars that are listed as row names, which is why it doesn't have anything right here for that. This is not a column, which is a little bit unusual in that way. And then tibbles are just a slightly different version of a table-like data set. And it does some nice fancy things for us. So this is basically the tidyverse version of things. So our ER data set is a tibble. It's going to give us our dimensions automatically. Here it's telling us it's a tibble. It gives us information about the class of our variables. For example, this is a character variable. These are words or strings here. And that information can be really useful to get super quickly. And that's nice. Also notice we don't have any row names. Everything that we have in here has a column name. So a lot of the functions that we're going to work with are going to work nicely with both tibbles or data frames, but we want you to know how you can make tibbles in case you end up working with a data frame and you prefer tibbles. There's a function called tibble that will allow you to transform a data frame into a tibble. So we can take the tibble function onto mtcars, and make a tibble out of this. But something happened here that is problematic. Does anyone notice what it is? Yeah, very good. Very good. Yeah, we lost our row names. So we are going to talk a little bit about how we deal with that. So generally, we recommend working with tibbles, but you might run into these data frames. Most of the functions are going to work for both of these. But if you do transform, you're going to need to be noticing things like that. That's the main thing. It's just we might lose our row names. So if this happens, so here we can see it, that first column where we had the names of the cars was in our original version, but when we made the Tibble version, we lost that. So there's something really easy to make sure that we don't have that happen. So there's this really nice function called row names to column, and that will create a new column called row name out of our row names. And so now when we make a Tibble, we don't lose that information. So just something to be aware of in case you end up trying to convert a data frame that has row names. Then we'll move on now to focusing on our ER data set. Remember, we've got our county information, some information about rates, the confidence about the rate, and year information. All right, so the first thing we're going to talk about here in terms of transforming our data is renaming columns. I imagine many of us here have probably worked with some unusually named columns that can be a little bit challenging. And so it can be nice to fix that. And sometimes our names just aren't very useful, right? Sometimes we want to make them more informative. So that's what this function does. It's really appropriately named rename. And so the column names that we have in our current data set are county, rate, lower 95 CL, upper 95 CL, visits, and year. These are pretty good column names. But let's say that lower 95 CL isn't necessarily the most informative for people who are just looking at it, or maybe it's CI. So we want to show confidence interval limit, right? We want to explain just a little bit more for people. So we could do that using our rename function. And the only, I'd say counterintuitive thing about this is we list the new name first. So the way that this looks is our typical setup of where we're assigning our object that we're either creating or changing. Then we have our rename function, the data that we're using. And then this is the part that's kind of different. We have our new name equals old name. So seeing this in our data set's a little bit easier to understand what's going on. We're taking our ER data set, we're renaming it to have a new name here for our existing lower 95 CL. So we're saying lower 95 capital CI limit here so that we can have a more informative name for this variable. All right, so let's take a look here. We could similarly do the same type of thing for our other column, the upper one, and that's going to change this column to be called upper 95 CI limit. So the new name is listed first. Notice that when I just put in this code, it prints out the results, but it's not actually going to change our ER data set. So if I take a look at head ER after doing this, I'm going to have those original names. So I have to actually reassign ER if I want to really change it. So here we created something new called renamed ER, and we saw the change here. All right, so there are some tricky things about column names that are really annoying in R, and it's a little bit inconsistent. And we're going to try to suggest some tips to avoid the annoyingness, but I wanted to point it out to you. So sometimes we're going to have column names that have some spaces or special punctuation or numbers, and that's going to often require special attention. So say we had the % sign in here. If we do that, we have to use backticks around the name there because R, anytime it sees a special character like that, is going to need those backticks. And that's annoying because every time we write in the column name, we're going to have to be using backticks. But, sometimes that's how our data starts out. And so we're going to need to use backticks for that. There's a resource here about backticks and quotes and when to use them and why. There's some inconsistency across some of our functions, which is annoying, but it's just the way it is when you have a free language like this that lots of people that are different contribute to. So what the heck is a backtick? If you're not quite sure, there you can see on your keyboard, it's typically the furthest left upper button underneath the escape button on your keyboard. It's also where you'll find the tilde, which we will use later in the future. So again, that's helpful for our column names that are atypical, that might have spaces. They might have numbers without a character. They might start with a number, or they might have punctuation. Underscores and dots are okay. R is happy with those, but otherwise, things like the percent sign, it's not going to be happy. But here's a solution. Let's get rid of those awkward names first, and then you don't have to deal with them anymore. Another thing to note, sometimes people use quotes instead of backticks, and that will work some of the time. If you copy and paste your code somewhere, like say you put it into the Slack channel or you put it in the chat here, it'll often convert your quotes to being a curly version. So notice how these look a little bit different. This curly version does not work in R. It's going to be unhappy. So if you ever get a weird error and you're like, I don't understand, and you're using some quotes, it's probably because you copy pasted. We can also rename more than one column at a time. We just need to put a comma. So here we're using the rename data set. We just have a little space here. We don't like that. We can get rid of that. It's nice to kind of put our code like this so we can see everything all aligned together. But we're going to put a comma after each thing we're renaming, or in between, I should say. So when we do that, we can rename both of these columns. Sometimes we have a situation where we want to rename all of our columns in some way. And there's a function that allows you to do that called rename with. So occasionally you'll get a data set where everything's uppercase, which can be kind of annoying. And you can change that to be lower, for example. So there's a toUpper function and a toLower that you can use to make things upper or lowercase. So here we're using rename with on the ER data set to upper, and all of the column names become uppercase. And then if we use the toLower function on that data set, you can see that we make everything back to lowercase. So to show you what that looks like here, we've made everything uppercase here. Sometimes we have really messy column names though, and it's just going to be a ton of work. And we really recommend you check out a package called Janitor. This is not part of the Tidyverse. You would have to install it separately and then load it into memory. Can't remember when I last installed R versus Janitor. So let's see if it's happy. So I have it ready to go. And we're going to show you why it's useful with a much more challenging data set. So this is also on our website. It's a data set about CO2 emissions from a bunch of different countries from 1751 to 2014. It's a really cool data set, in my opinion. So if we run that in, notice that it's showing a column names with some numbers here. So notice that my column names are numbers. They look pretty clean here, but when I try to use them, I have to use backticks every time. And every single column here that's numeric, that has this number, which we've got a lot. We've got 265 columns, and only one of them is not a problem. So that's annoying. So how can we fix that? So notice here, if we look at it in some different ways, we can end up seeing these backticks here. This is just because it's printed out from onto our slide. We can use this clean names function from the Janitor package to fix that. So that's going to put an X in front of the number, because we can't have column names that start with a number. We can have column names that end with a number, have a number somewhere inside. But otherwise, if it starts with a number, we have to have backticks when we refer to a column, but not if we have this X in front of it. So using the clean names function, it's going to put an X in front of all of those years, which is really convenient. And this function's really smart. It can do a lot of things. Like say we had, it's going to do it for every single column that it thinks has a problem. Notice it doesn't do anything to country because it looks good already. So it can also take care of things like spaces, which is a really common thing to have. So here we've created a tibble where we've had to use backticks here because we have spaces, and we've added some information here, some vectors. So we have two columns, one called column 1, which has a space, and one called column 2. So every time we refer to these, we're going to have to use backticks, which is annoying. But if we use the clean names function on that, it converts it automatically to an underscore, which which is really cool. Because if we had 1,000 columns that had spaces, it would do the same thing. So which of the following would not always work with a column named counties underscore of Seattle underscore population over 10,000? Notice it has a comma here. It's also really long. Would we want to maybe A, rename it using the rename function to something simpler, doesn't have a comma? Would we want to keep it as is and use backticks around the column name when we use it? Would we want to keep it as is and use quotes around the column name when we use it? Which would not always work. Now, this is a tricky one. Tried to make it a little tricky on purpose. So indeed, A would be a great option. That one would work all the time. That would be the ideal thing that we'd probably want to do. If we were to use backticks, that would typically work all of the time. Quotes are sometimes going to work, but the ideal situation is to do A. But the question was, what will not always work? And that is quotes. So like I said, our suggestion, just rename those ugly columns, make them nice. Then you don't have to worry about it. All right. So in summary, data frames are a simpler version of a data table. Tables are a fancier version. They've got that information about dimensions. They've got class information. Both of them are basically these tables with rows and columns. If you want to make something into a tibble, you can use the tibble function, but watch out for those row names. If there are row names, you're going to need to use the row names to column function first. So just be checking your data. If you suddenly notice, wait a minute, I used to have a column that's gone. That might be what's happening. Technically, it's not a column, but it kind of looks like one. The rename function of dplyr can help you rename your columns. And we especially think it's a useful thing if you have awkward things like punctuation, spaces, or just numbers. That way we don't have to use those backticks around our non-standard names. You'll see that sometimes quotes work, but really backticks are the way to go. Avoid copy and pasting code from other sources, especially if you're looking at quotation marks, because that will change your quotation marks to be curly very often, and then it will not work. If you have lots of column names that need changes, highly suggest that you check out the Janitor package. I don't think we need Janitor for the lab, as I recall. All right. Any questions before we get into the lab? We've got some cheat sheets here for you as well. Okay, sure. Yeah. The head function. Yeah. So our head function allows us to take a look at the top 6 rows of our data sets. We can actually specify with an argument if we want to just see a different number. It could be a small number, it could be a big number, but it's just giving us the top or the head of our data frame. Conversely, tail is going to give us the bottom of, so this is that's a bad version. Let's go to 1. This is going to be the very last row of our data table. So head's the top, tail's the bottom. All right. We are ready then to jump into lab.
Hey everyone, we ready to get a little bit of practice with this? We're finally starting to kind of dive into some of the data and structure it and start to turn it into what we want. Yeah. All right. So if you go to the materials and schedule, we're on to day 3 and the lab RMD files are right there. And I'm actually going to switch back to my other project. So bear with me for a moment. So I'm in that project that I created yesterday, and I'll open that lab file back up. So I'll give us a moment to get to that, and hopefully your file looks a little bit something like this. If anything comes up, chat is wide open. If you want to just let us know if anything's looking wrong on your end, or, maybe we linked a file incorrectly somewhere. It's always possible. All right, so let's get into it. I just opened up RStudio, so I am going to need to make sure I load my packages. If you kept it open from yesterday, you might already have them loaded, and in which case you're a little bit ahead of me. So I'm going to hit that play button to run the code, or I could kind of highlight it and hit my shortcut. All right. So again, we're going to work with this Cal Enviro Screen data set. It has information about environmental factors associated with human health in California. So I think I mentioned it yesterday, but they measure things like ozone and particulate matter and, just things about the environment that might affect somebody's risk for health outcomes. And so let's go ahead and load the data. You can just run this code here, or you can do the point and click method with this link. Whichever way you want to get a little bit more practice with, totally up to you. And so I am going to highlight this, or just even put my cursor right there and hit either Control or Command Enter, depending on what computer I have, and run that code. All right, so check that it worked by seeing if you have the CES data. How would I check that that data got read in okay? Is there anything going on in my RStudio that I could look at and think, looks good? I know that that happened. I know that that was successful. There's tons of right answers here. Yeah, check environment, right? So I can see that the CES object is in my environment. That looks good. Anything else? Yeah, exactly. So what if I do this and hit enter? That looks good. I see some data in the console. So if I typed in a object that did not get read in, it's going to say it's not found. So always a nice way to do things. All right. So what class is CES? We know it's data, but I could even kind of scroll up here and I can see that when I type in the name of the object into the environment, it's telling me it's a Tibble. And kind of a silly name, but Carrie mentioned just a moment ago that it's like kind of like a fancy spreadsheet. Yeah, exactly. We get 4 answers. It's kind of a mouthful. So yeah, so I get that too. It is a Tibble, which is what we see with this answer. But anytime we have a Tibble in R, it's going to give us all of these classes because technically it is a data frame. It's a spreadsheet, but it's got some extra flavor on it. It's a little special. And so it tacks on these 3 additional classes here. But just a long and roundabout way of saying I have spreadsheet data. If I scroll up a little too, the cool thing is that when I get a preview of the data here, it actually is telling me what class all of the columns are, because the columns can be different classes. So I have character data for the county, that's text data. And, if I go over here to this environmental score, which is kind of like a measure of risk here, goes from 0 to 100. This is a special numeric class. We'll talk about that in a bit, called a double. Means it's very precise. All right. So again, lots of ways I can answer this question here. How many observations, rows, and variables columns are in the data set? Try the dim function. We can do that for sure. Any other ways I can get this information? Exactly. Yep. So we could check the environment. I don't even need to put any code in because again, where did my pencil go? Come back. I could see those dimensions right here as well. And I could even scroll up in the console and see that information right here as well. All right. And I think somebody pointed out that the key was 1 off. It says 68 columns instead of 67, but the environment doesn't really lie to us. So I think the key is a little off. I'm not sure what's going on there, but we'll look into it. So next we're going to rename California County to CA County. This is already, that name's okay. But maybe I'm getting a little tired of typing that out and I don't want to type it out again. So I want it to be a little shorter. And so maybe I want to rename that column name and let's see how we could do this. So I could use the rename function and we're going to dive in a little bit. Okay. So no need to get worried. We have to supply a couple things. So first thing, we want to tell it what data set we want it to work on. And that is the CES data set. And then we have to be specific about the column that we want to rename. If I were to pop this open, I want to use the California County column. It says, watch out for the order of new and old names. So this is maybe a little backwards, but the one on the left, we're actually going to start with the new name. So we could do CA, county lowercase. That's how they asked for. And then is going to be equal. So I'm replacing California County. All right. So what happens if I run this? All right. So if I look in the console, I can see the new column name there. But if I look at my object, I don't see that change. It's still California County. So what did I do wrong here? I'm probably going to want to reassign it so that change actually takes effect. So CES for that object name, and I'm going to solidify and reassign that change. So let me run that again and then take a look at my object. All right, that looks more like it. So a couple things that I want to point out that you might get as far as errors go. So let's say I'm just going about my data analysis. I'm thinking, okay, I want to rename a column. I want to rename longitude. I want to rename that one. I'm going to just rename it long. And let's say I spell the old column name incorrectly. Let me do it all caps, right? That's not right. And so what happens if I try to rename a column that actually isn't there? It says can't rename columns that don't exist, right? It says column longitude doesn't exist. I'm like, what do you mean it doesn't exist? It's right there. The case matters. So if I fix it to be spelled correctly or capitalized correctly, I should be okay. Another thing that sometimes happens is if I try to run this code again, what's going to happen? Let me just run this and see what happens. Anyone, this is very, very tricky. Anyone want to guess why I'm getting an error and why it's telling me that California County doesn't exist? Exactly. I already changed it. So basically, California County is gone, right? I totally replaced it. If I wanted to try to run this again successfully, I could be real sneaky. I could run all chunks above and reset the changes I made. So if I run chunks above and then run this chunk again, no errors, okay? Because it is basically resetting the code for me, okay? So if you have run a line of code a couple of times and you're getting some sort of funky errors like this, it might mean you need to go and backtrack a little bit, run the code before. Okay, any questions about rename here? Yes, very tricky. So rename is a function from the tidyverse, and the tidyverse has sort of tried to be smart and make our life a little easier. So after you supply the data set in the form of an object, it kind of assumes you're working with column names. And so anything you supply it should be okay without quotes. This isn't, unfortunately, it's not always consistent, but generally the tidyverse functions can work without quotes. But yeah, you're exactly right. It's typically these would be text that's in quotation marks. Other questions about rename and just kind of what we're doing? All right. Well, let's take a quick look at another way we can kind of clean up our column names. Always nice to keep them organized. So let's use a function called rename with to basically give us a little shortcut, right? Maybe I don't want to have to go and rename every single column in my data set because there's 67 of them. That's a lot. I don't want to do it all by hand. And so rename with is actually going to let us apply or kind of basically use some kind of modification over all of the columns. So maybe I want to rename with to upper to turn everything into uppercase. And I want to call this new data set that I'm cleaning up, I want to call it CES upper. And so anytime you're kind of creating a new data set or cleaning one up, creating a new object, you're going to have that on the left-hand side. And we're going to use that assignment arrow. And so what are we going to put inside that object? We're going to do a renamed data set. So let's say rename with. Okay, so just like with rename, the first thing we got to supply is the data set. We got to tell it what to work on, right? Like, what do you want me to rename? You got to supply me with something to work with. So let's start with CES. And then instead of telling it new column equals old column, let's use just to upper. It's going to know that I want to do it to all the columns. So let's try that. All right. So this is a good sign. It created another object and it's the same dimensions. So I didn't want to drop any columns. I just wanted to rename them. So let's take a look. All right. That looks pretty good. Okay. Any questions about rename with? How we did that here? Yeah. So rename the rows. How do you mean? Like the numbers here? Yeah. So we could do supply some row names. I find that that's not as common just because that information could really be in a column instead, but it's possible. So you could say the row names of the data set could be, something that you supply. That's fine. You can do that. But we will talk a little bit more about how, like, let's say we wanted to kind of clean up a column and make the names inside the cells different. We'll talk more about that. Yeah, but typically, what Carrie was talking about with like the names of the cars disappearing. Generally, I try not to name the rows. I just go with the 1, 2, 3, 4. And so just, one more thing, this is a function here. So typically, like if I were to type into upper, typically functions have the parentheses around them. And so if I ended up like doing something like this, it is going to give me an error. And so just when we're using it with rename with, we kind of have a kind of funky notation where we just exclude the parentheses. Select number of columns. Do you mean like... Yeah, good question. So this will not, it's not going to create an error if the column is already capitalized. So that should be okay if that's, the concerns that some of them aren't capitalized and some aren't. But let me see if we can specify. So let's actually look at the help page. So by default, what you're telling it to do is to change everything, to change all the columns. But if I wanted to provide like a little bit of a vector of columns, like let's say I wanted columns 1 through 10 to be 2 upper, I could do that, but I just have to be specific about it. Yeah. By default, it's like, I assume you want to do everything. Anything else about these? How would you call out just one column to be uppercase? So there's a couple ways we could do that. So we could do rename. Let's say I want census tract to be all caps. So something like that. So that's just one. We could also do rename with, like I was saying, we could be specific about the column by specifying the dot calls argument. So dot calls equals census tract. All right. So same thing. All right. So I think we'll head back to the main session. If there's any other questions, so we're about at break time, but if there's other questions, feel free to ask or to put on Slack if you want. All right. Nice work, everybody.
We're going to move on to part 2 here, which is about subsetting columns. Now that we've renamed our columns in ways that are easy to work with, we can now subset them. So we're going to work with our ER data again. And because I'm starting from scratch here, I'm going to read it in again. And I'm going to make a smaller sample. So I'm going to do a slice of just 30 random rows. Did not assign this to my ER30. There you go. All right. Now I've got some data here to work with. Okay. So there's a couple of ways that we can subset columns. And by subsetting columns, I mean that we can look at an individual column or try to determine which columns we want to look at. So one of our functions is called pull, which is going to pull out the values for a particular column. So if we use that on our ER30 data and we pull out the year column, it's going to print out all of the values for that column. And that can be nice if we want to look at a column and make sure that there aren't strange values. Even if the data set is quite large, if we just look at one column at a time, we can often see most of it. So here, I'm going to clean this up a little bit. I'm going to take a look at our data first, just to be aware of what we have here. So these are my different column names. I'm going to take a look at pulling out just, so I'm going to do the 30, a smaller data set, just the visits column. Actually, you know what? I'm going to do county so that I can see how many different counties I have. All right. So now I can see the different counties that are in my data here. So as you can see, this is a good way to investigate the different values. Alternatively, I can use a function called select, and that's going to keep it as a tibble. So notice that I have everything listed in this long format. It's in a single column. All I've done is basically taken my data set and made it small. So if I change this to select, I have now just made it to be that one column. So here I had a bunch of columns. Now I have just that one single column, but it's in a table format. This is nice because if we don't want all of our columns, we can select the columns that we want. So maybe I'm only interested in these 3 columns. I can select for those columns to make my data set even smaller. So over here, I see that I have about 6 columns here. I'm only interested in year, rate, and county. So I can select for those columns and I'll get a data set that looks like this. I could use poll to do a similar thing, but again, in that case, I'm going to pull it out. It's not going to be in a table format anymore. And it's kind of weird to use poll on multiple columns. I'll show you what I mean here. Yeah, in fact, sometimes it doesn't even like it. Like it may have misspelled country for county or something. Let me do something new. Yeah, so this is kind of weird looking. It's hard to see what's going on. I've got basically the different columns appended to each other. I think this is very unclear. It's not really easy to see what's happening here. So I don't recommend using the poll function with multiple columns. It's really for looking at an individual column at a time. Okay, so remember if we use poll, it's going to look something like this. Does not look like a table. All right, sometimes we have columns that have similar names, and we might have a lot of different columns that have a similar name. It's not uncommon to have, in the hundreds for the number of columns that we have. And we might have 50 that end with some suffix or something. And so in our case, we have a couple that have this CL here, and it could be that we're really interested in the confidence that we have in our data. So maybe we just want to select out those columns. We could do that using the select function and something called a tidy helper. And so this one looks like ends with, and so that's going to select every column that ends with this pattern. Because this is a pattern, a character pattern, we need quotes around it. So I'll show you what I mean. This is selecting out just these 2 columns. If I don't put quotes, it says that CL is not found. So if you ever get that error, that's what's going on. And these helpers, there's a bunch of them that can help us. They can help us get things that start with something, things that end with something, or something that's some pattern that's inside of our column names. And if we're not sure what these are and we can forget what they are, we can type in tidy select and it's going to show us all these different options. To be honest, though, I really just use these the most. Starts with, ends with, and contains. So this would also work with contains because these are the only columns that contain the pattern CL. However, if I tried to do starts with, it's not going to work because they do not start with CL. Contains is nice also, though, in case we have a pattern that is internal to this. So say we wanted to do ER, for example, or 95, then that would be useful. So let's try that. That also works. We can combine this with our typical selection. So here we're selecting for columns that end with CL, and we're also selecting for the year column. And if we just include a comma in between, and whatever we list last is going to be placed there. So it's going to show up in the order in which we ask for them. So similarly, I could do this, but then I could say year here, comma, to start. So I can easily combine those together. I can also combine different helpers together. So here I've combined 2 different patterns. I've combined looking for things that start with R and looking for columns that end with CL. Sometimes we want to specify columns of a particular type or class. So in particular, it's useful to get those that are just character or just numeric. Just numeric is especially helpful because sometimes you want to apply mathematical calculations to things. And then it's helpful to specifically have those columns. And we can use a function called where combined with is character or is numeric to get those particular columns. So we're selecting of the ER30 where the columns are numeric. And so notice here that county was not included in our columns that we selected for here. Okay, I got check. What function would be useful for getting a vector version of a column? Is it pull or select? Select and pull work a little bit differently. Yeah, so indeed the answer is A, pull. So let's take a look at this one more time. So if we select for the year column, we still have a table here. It's got one column, but it's in table form, meaning it's listed out in this long format. But if I want a vector format where I can see all the values, if I use pull, I'll get that like this. See how much easier it is to see all the values here? Even if I use the original data set that has a lot more values, I can scroll through pretty easily. And I can see that I don't have any weird values. And this is important because sometimes we're going to have functions that require a vector. Alternatively, we have some functions that require a table, and then we need select. All right, any questions before we move on to subsetting rows? Okay, so the main function we're going to learn now for rows is the filter function. So filter is for rows, but it's going to use columns to figure out which rows we want. So it's going to make conditions to satisfy, to pick out the rows that we particularly want. So we'll see what we mean by that. But we're going to filter down our data to only have certain rows that match things that we want about our data set. So for example, we can use the filter function on our data ER30, where we say the year has to be greater than 2020. If we do that, we end up with only 4 rows, not 30. So we've lost 26 rows. We filtered down to only the rows where the year values, so the values in the year column, are greater than 2020. So let's try that over here. Notice we have this small data set, but we know that our ER30 data set has 30 rows, as we can see from over here. Let's try something different, like 2017. All right, if we do 2017, we get 10 rows. Notice that all the years are above 2017. Note that they do not include 2017. They must be greater than 2017. Okay, so there's a bunch of different conditions we can use. We can do the greater than or less than. We can also do exact matches too. So I think of this as exactly equal to. We have to use 2 equal signs in this case. And the reason is because R thinks a single equal sign is an assignment of an argument or an object. So notice how we previously had some cases like, for example, the head function, we could do n equals 2, right? This is what R thinks a single equal sign is going to do. It's going to tell an argument what to do. So if we're telling it it's a condition and it exactly equals something, we have to have 2 equal signs. This makes it easier for not equals. Then we put not equal to. That's if we're trying to look for things that are not equal to a condition. And then we can have greater than or equal to or less than or equal to. And we can also include multiple conditions with and logic or logic. And we'll talk more about that in a second. We're going to see some examples of all of this. Note that you can run into errors with filter. One is that you misspell a column name. If you misspell the name, it's not going to know what to filter. Or maybe you selected out the column. If you select out the column, there is no column to filter, so it can't work. So let's see some examples here. So we're going to filter the ER30 data where the rate is greater than 9 and year is exactly equal to 12. If we try to filter for that, we're going to end up with nothing. Turns out there is no data in our data set that has that condition. So let's try this out and try to walk through what it means. See if we have other data sets that we can try, or other conditions. I should take a look at my data so I know. We've got some rates that are greater than 0, and they have the year 2021. There we go. So I said the year needs to be greater than 2020, and the rate needs to be greater than 1. Notice we can use a comma, or we can use an ampersand. I like this much better because it's much easier to read. it's clear to me that I have to meet both conditions to be kept. The row has to meet both conditions. So the year has to be greater than 2021, and the rate has to be greater than 2020. I can also use this or condition. This is a bar that's typically the key that's below our delete or backspace key on the upper right of our keyboard. And that helps us to say that we're okay with rows that meet either condition. So either the rate can be greater than 9 or the year can be exactly equal to 2012. Notice we have some situations where the year is not 2012, the year is 2021, but the rate is greater than 9. So this row gets to be included. And in this case, we have a rate of NA or a rate of 0, but it gets included because the year is 2012. So when we had the AND logic for this, we had 0 rows because we don't have any rows that happen to meet both conditions. But when we say or, we get 6 rows. So rows have to only meet one of these conditions, not both. All right, any questions about how that works? We'll see more examples and we'll practice it as well. So that'll help to integrate some of that. Sometimes we have a situation where we have a bunch of different patterns that we're trying to exactly match. So for example, say I want county to be exactly equal to Denver, exactly equal to Larimer, and Pueblo. I could do this where I say it has to be exactly equal to Denver, or the county has to be this, or the county has to be this. You can see that this could get really long and tiresome. So I have this really cool in operator that I can use. It's a %, the word in and percent. And I can use that to check across a list. So it'll say for the ER30 data, filter for rows where county is in this list of possible values. And that will give me the equivalent results. So now I can see that only the counties that I requested are filtered out. I only kept those rows. So similarly, I could do something like year in, and I'm going to say 2020, 2021, 2022. Oops. Need my closing parentheses. All right. I can see that I filtered for all of these different rows. I have 2020, 2021, and 2022. I do not have years for other rows though. So it got rid of a substantial number of my rows because I had 30 and now I only have 7. I can combine this in multiple ways. So I could do it for 2 different patterns. So here I'm looking for rows of years, and here I'm looking for different counties. This is going to get me anything that has rows that match both of these. Notice that filter is a little bit tricky, so it's really best to stick with the column names for our functions when we're using filter. We don't want to put quotes around our column names. So if I use this here, year is greater than 2014, I will get incorrect results. So notice that I got 30 rows, which means I didn't filter for anything. I have rows that have 2012, 2014. These should not be showing up. And that's because I put quotes around year. So I try this here, I get 30 rows. If I get rid of those quotes and I say use the column year, not the character string year, but the column year, then I get only 19. And I filtered it correctly. You can see that year is always greater than 14. So the way that we can check for this is to check the results. Are we getting a change in the dimensions? Is it what we expect? Are we seeing what we think we should for that variable? It's really important to check. When we have those atypical names, like punctuation marks, for example, say we added an exclamation mark for a year. Here I'm renaming it. So this is the new name. Then when I try to filter this column, I have to put backticks around it. If I use quotes, it will not work. So notice I have data for 2012. I have all the rows still. I did not filter for anything. If I use backticks, it works. Again, the solution for this, though, fix the column name ahead of time. Then you don't have to worry about this. Similarly, if we use county here we're doing it yet again. We're putting quotes around the column name. Shouldn't be doing that. We might forget, though, because we need it for our character string that we're checking for. This is going to give us nothing. If I get rid of those quotes, this is my column name. It should not have quotes. Then I see that it filters correctly. So the moral of the story is no quotes around our column names. And if you have weird atypical column names, I suggest you make them typical so you don't have to worry about confusion with this. Quotes only go on the actual values, not the column names. And don't worry too much because you'll see things like, wait a minute, did that work? I thought I'd have some rows with Denver. So maybe I need to check what I did here. And then like, oh, okay, yeah, that worked. That was right. So yeah, filter can be a little bit tricky with those special column names. That's why we suggest you rename them ahead of time and always check your steps. Did it go the way you thought? Did the dimensions change? Then you can be careful with what you're doing. Any questions before our gut check? All right, so if we want to keep just rows that meet either of two conditions, which code should we use? Should we use filter or select? And should we use this symbol or this symbol between our conditions? Got some brave people, got some differences in opinion, some thoughts that maybe it's either or. All right, so we definitely want to use the filter function because that's for our rows. Select is for columns, filter is for rows. If we want it to be either or, it's okay for the conditions for either of them to be met. And we want to use the or operator, which is that bar that's under the delete or the backspace key. So the answer is A. C would be if we had wanted it to meet both conditions. It had to meet both of the conditions. All right. In summary, we have pull to get the values pulled out of a data frame into a vector, and that's good for checking a column and figuring out if the values are what we expect. So that was, if we did something like this, but if we use select, that is going to give us tibble that's smaller. It's just selecting only particular columns. Okay. We can use select based on pattern names. So we can use patterns and we can use functions like starts with or ends with so that we can select for particular columns. Or we can use it in combination with the where function to specify where it is numeric or where it is character. We can do multiple tidy select functions by just putting a comma in between. And we can even do multiple patterns if you wanted to do that. In this case, you're going to need to use the combine function. Our filter function is, however, for rows, and it's based on conditions for the values within our rows for particular columns. Be careful about using quotes for column names. We really shouldn't do that. It won't work for filter. The double equal sign is the same as exactly equal to or equivalent to, and that's when we're looking for patterns or rows where we match a particular value. The ampersand is when we need both conditions to be met, if we want those rows to be maintained after we use filter, whereas the or operator allows us to meet either of the conditions. Any questions about this material before we jump into lab part 2, which will help us to practice some of this? I know it can feel like a bit like quite a lot, but it's easier once we do some practice. All right, I think we're ready to go to our lab then.
All right. Any thoughts, questions, feelings we're having about this stuff before we jump into part 2? All right, we've got one thumbs up. The last question in part 1. I think we did go over it. The practice question, we're typically not going over those, but they're intended to kind of be extra practice if we're interested. But definitely, like if you're working through these practice questions on your own and you're like, I don't get it, I'm a little confused on it, feel free to put a question in the Slack or in the chat on Zoom, or even try to catch us right before a break or something like that. Because there's definitely like things that we want to make sure we have time to cover, but there's like always more practice we can have, right? So we want to give you a little flexibility in terms of like, do I just want to cover the the kind of, I guess, the questions that everyone's going to do, or do I have a little bit more time today to kind of go through things myself? Yeah. Part 2, we're going to create a subset of this data. Okay, so we learned about 2 functions that are super helpful for helping us narrow down our data set. These are select and filter. And so we want to just pick a couple of columns and we're going to use subset for that. And so these are kind of descriptions of what these columns actually are in case you're interested. Census tract is that kind of spatial area. It's like a smaller area than a zip code. This is a traffic density. So more traffic you have in an area, the more particulates and more pollution you're going to have, maybe more asthma and things like that would result. So with that being said, let's create a subset. I'll give us a minute to play around with that. Alrighty. We're going to want to create a subset of CES. So what do we want to start with? We're creating a new data set, a new object. We did that up here. We created an object called CES upper. So what would be the first thing that I type here? Any guesses? Yeah, exactly. We want to create that new object. So got to give it a new name and we got to give it some content. So let's use that assignment. And we'll want to use, as I mentioned, the select function. Okay, this is going to let us subset the data. And just like with rename and rename with, we'll want to give it the data set to work on first, CES. And then from here, we want to tell it specifically, what are those columns that we want to use? And so we could list them out. So I want to make sure that I spell them right. So we could do census tract, traffic, and asthma. All right. So I didn't get any output in the console here because I was assigning an object, not just printing it out. So I could just go over here to my environment to check it out, click on it. All right. So much smaller data set and maybe a little bit more manageable if, maybe I'm not interested in all those other environmental parameters. I'm the asthma scientist in the group or something like that. Or this is like something I'm interested in for a project. And so I could subset it just to make things a little easier to look at. And I don't know if we mentioned it, but the cool thing about the spreadsheet viewer is I can click on the columns and I can actually sort them. So if you wanted to look at like the max and min, that's pretty easy. Just click on the columns and sort it out. So what happens if I am, I'm playing around with my data, I'm selecting some columns, but I actually spell a column incorrectly. We were capitalizing things earlier. So what happens if I do this? Same thing as before. I can't select a column that doesn't exist. Column asthma doesn't exist. So it's I feel like a pretty helpful error message. It's saying, whatever you supplied me does not have that column in it. It cannot be found. You might want to go check out your data and scroll around and actually see what columns you do have. So maybe I go and check out my data here and I could see, okay, asthma is capital A, lowercase letters. So I could be, okay, I got to correct this here. Okay, no error message the second time. And if I check that out, it looks good. Okay, so making sure we spell those column names correctly. One last trick up our sleeve here. Sometimes with tidyverse functions, we can hit the tab button and it will give us the options as far as columns go. For some reason, this one's not, but you can occasionally do that. And that way you can prevent spelling mistakes and things like that. Okay. So yeah, we have a smaller data set now. Good stuff. All right. Again, moving some of my windows around. All right. So let's start with CES again. And instead of the data set we just made, so let's ignore this one here, CES sub, let's use CES. We're going to subset it again to include census tract and the columns that end with percentile. We're going to use select and ends with. So this is sort of a programmatic way of selecting columns, so we don't have to spell every one out individually because that would get kind of annoying. So let's give that a try. All right. So we're going to call this CES2, and we're going to assign it some values, again, with select. And we may be seeing a pattern here. We always want to start with the data set, CES. All right. So if we want to to select the census tract column, we would do just like we did before, right? We would just type out that column name. And again, we want to select those columns that end with percentile. We're not so interested in writing out every single one. I've got a lot of columns in this data set, right? So I'm actually maybe not sure how many there are. I don't want to miss one. So I could say I want to select any column programmatically. I want to select any column that ends with, and notice I got this little yellow box that popped up. It's going to ask me for match. It wants a piece of text that its job is to look for. So I want to end with some text PCTL. All right, let's try that. Okay, let's look at CES2. What have we got going on? All right, I have census tract, but then I have all these percentiles for different environmental measures. And I'm glad I didn't have to type those out because there's a bunch of them. There are 24 or 23 since minus census tract. Yeah, so tons of columns here. Yeah. So those tidyverse functions that I mentioned, so things like select and rename, they have kind of like a special exception for columns. And so they don't require quotes around column names. Sometimes you can have them. And for functions like filter, it actually messes things up. So typically we don't put them around the column names. But if it's just it's like a piece of text that's being looked for, or maybe like a value in a cell, then you would want to put that in quotes. Yeah. So anytime, that's a good question. So I'll put a little note here. Columns names don't need quotes, but text matching does. All right. And if you're curious more about how ends with works, one thing I do love, I know the documentation is a little bit hard to read sometimes, that it can be a little jargony. But one thing I really like is to scroll down to the bottom and you can see examples. And I think the examples are really helpful. So like, for example, it's selecting columns that start with WK and showing how that looks there. So I think that can be helpful as you kind of continue on with your R journey, the examples at the bottom. All right. Okay. So very important thing here that we're going to take a look at, and that is pulling the variable asthma from the data set. How does this differ from selecting it? And we'll use head to look at both options. So let's do pull from the data set. So CES sub, and then what do we want to pull? We don't need quotation marks because this is a column name here in a tidyverse function. It's just a long string of numbers, right? It's like a long sequence. Versus if we select from the data set, how does this look different? This looks a little bit more like a spreadsheet, right? It's a single column, but it's still, Tibble format, still sort of like a spreadsheet format. Yeah, so it'll still run, but if I just wanted to look, so head is really good if you like have something really long and you don't want to see the whole thing. You just want to see the first couple of lines or items. Okay. So we could certainly do head there to compare side by side. Sometimes I like to not follow the directions. All right. So yeah, I've got a couple here and more of a spreadsheet going on here. So the very important thing to take home from this is, even though the values are the same, right? So the Tibble kind of cuts off some digits. It's just trying to clean things up for you. The number is the same in the object. These numbers are the same, right? However, when we pull a column, we are making a vector. And so these are, kind of a format of data that we talked about earlier compared to a spreadsheet. These two different formats are going to work differently with anything you give it afterwards. So like, let's say you wanted to do some summary statistics. We're going to talk about that tomorrow. A lot of those are going to need a vector and not a Tibble or a data frame. So you're saying, I want to take the average or the mean of the asthma column, I would need to pull that column first. But if I'm just interested in kind of looking at it in tabular form, select is just fine. So I can even see that with class. We talked about the class function a little bit. So this one is a vector of class numeric. This one is a data frame with one column. All right. Yeah, just a kind of a jargony, perhaps, discrepancy there, but I promise it's going to come up throughout the class. Okay, questions about pull and select. I think the next thing we're going to do is subsetting some rows. So we're going to actually pivot over to filter. Well, let's take a moment and see if we could get some code down to subset the rows of CES sub that have more than 100 for asthma. So we're going to try to do a comparison, right? We want asthma greater than 100, and we want to make sure that all the rows of the data meet that criteria. So let's take a moment and see if we can figure out some code here. All right. So we're going to use filter, right? So anytime we want to kind of narrow down the number of rows we have in the data, this is the same thing as if you were filtering like an Excel spreadsheet or something like that, where we're narrowing down the number of rows. So let's take filter, and just like select, just like rename, what comes first? I'm going to keep harping on this. First thing that we supply inside the function. Yeah, we're going to put that data set inside first, and then a comma. Yeah, whatever the data set name was. And then we want to tell it exactly what we want that comparison to be. So it says they have more than 100 for asthma. So kind of the way we'd format that it is as column, operator, and then like whatever number it is. So asthma greater than 100. All right, let's see what that looks like. So I'm just going to run it. I'm not actually assigning it to an object. Sometimes I'll do that just to kind of get a preview in the console and just do a gut check that it looks right. Okay, so preliminary gut check, I am seeing asthma values greater than 100. Remember, if I had quotes on here, it's not going to actually register. It's just going to give me back the original data. So I do want to make sure that I have just the column name and no quotes there. So that looks right. Now that things look correct, I'll go ahead and reassign it. So taking a look at my environment, I'm now seeing that the number of observations is a little bit lower, right? I filtered things because the original was like 8,000, right? And I still also have the selected kind of subset of columns as well. So we'll need to make sure that we do this part, right? So we have to reassign it. Yeah, and then make sure you run it. Yeah, exactly. Okay, so last couple here, we want to get a little bit more complicated. We're going to subset on two criteria, right? Like sometimes you want to filter not only, you want to look for asthma greater than 100 and some other criteria. So I'm actually going to copy this code and actually probably just this part. Okay, so we want an additional filtering criteria and we want it to be more than 100, but also the and is the key word here. Traffic less than 500. And so let's do and. If it was or, we could do that vertical pipe. Traffic is less than 500. And let's run this. Let's see what happens. All right. So just taking a look at the dimensions, I only have 130 observations or rows that meet that criteria. And again, if I try to filter on something that is not a column name, it is a little bit more confusing because it thinks actually that's an object and it doesn't recognize it as like a column that you spelled incorrectly. I think the the select and the rename function are a little bit smarter like that. So if you get a weird error, just, make sure your column names are spelled correctly. Also, important that if you want to filter, columns between values, so something like asthma greater than 100, you'll need to do, let's say we want also less than 500 or less than like 200 or something like that. We would have to repeat the column name twice. We can't actually do something like this. That will not work. Alrighty. Questions about the kind of multiple filtering here. Okay. So subsetting the rows that have traffic value less than or equal to 500 and asthma more than 100. How many are there? So let's copy this code from the previous question and see, we only really need a super small change here. So same data set, and then traffic value is less than or equal to 500. So less than or equal to 500 or 500, and an asthma value of more than 100. That still looks correct. All right, let's see what we get. All right, and looking at the results here, running both this one where it was just less than, I had a result of 130 rows. And then when it was less than or equal to 500, I got the same number of rows. So looks like I'm not actually encountering any traffic that's exactly equal to 500. So we get the same number of rows for these questions. Okay, so any questions about filtering or selecting? So that's another option. We could even see how that works to give us the same answer. Anyone else try anything a little bit different? All right, well, let's head back to the main session if there's no more questions. Yeah, I want to say it follows kind of the order of operations you give it. So it would, it's not like and or takes precedent. So that may affect kind of the order you choose to put things in.
Yeah, we're going to learn something in the next section that's going to make that a lot more obvious and clear, and it'll help that a lot. First of all, you should give yourself a pat on the back. You have gotten through 2/3 of subsetting. We're doing great. And now we're going to kind of combine some things and take things a little bit further. I think some of this is kind of exciting and fun. So, all right. So we're going to be working with the same data. Here I've just copied the same thing, reading in that ER data, setting a seed, getting that sample of it. I'm importing the data again, making it that subset so I have a smaller amount of data to work with, and take a look again at our ER30 data just so we know what we're working with. So we've got that county information, rate, confidence stuff, and year. All right, so we can combine select and filter if we want to do fancy things. So in this case, we are going to filter first for ER30 year greater than 2012, and then we're going to select just the county variable. This is what's called nesting, which means that we're putting functions inside of other functions. So this is another example here where we've got the select function. We're selecting some columns, a couple of columns, year and county from the ER30 data. And then we're using the head function to get just 2 rows. This is okay for this sort of thing. It's fairly easy to tell what's going on. It starts to get a little confusing, right? It can be kind of hard to tell what's going on, especially if we have lots of different conditions that we're filtering for. It's hard for me to tell exactly what steps are happening first and what steps are happening second. So one way to do this is we could assign a temporary object, meaning we just keep updating an object, right? We could first do our filter step and then select the columns that we want. That's one option, but there's a better option, and that is the pipe. So the pipe is this percent sign, a greater than sign, and a percent sign. So not to be confused with the in operator. They look very similar. So remember, the in operator looks like this, and that was for looking at multiple patterns or that we want to meet a condition for. but this is instead percent greater than percent. And I think because, it's got that arrow, it's helpful to sort of remember that that's for the pipe. So it's saying kind of like a then statement. So we can kind of read what we're doing from left to right. So here in this example, we're saying, let's take the ER30 data, then let's filter it for year greater than 2000, and county also has to be exactly equal to Denver, and then select for the year and the rate column. We can use a shortcut if we want to be using these quite a lot. You can use the command or control, depending on your operating system, plus Shift and M. Of course, you don't have to use that. You can always just type it out. Okay, so that could look something like this. And that's going to filter our rows. So notice sometimes people put them on different lines. It makes it really clear what's happening, that we have this filter step and then this select step. And the nice thing about this is we could maybe test out to make sure it's doing what we think it is for different pieces of it. So I can see that when I filter this, I get it down to one row, but then I want to just select the year and the rate. And when I do that, I get just these two values. Okay, and sometimes you'll see this one step here being part of the filter, just like we previously saw it. You don't have to pipe in the data, but I think it looks quite nice to do that. Makes it really nice and clear what's happening. Right. Any questions about the pipe before I move on? All right. I think the pipe is super cool. I love using it. It's life-changing, really. Okay. Now we're going to talk about adding and removing columns. So this is going to look a little complicated at first, but we're going to be using a function called mutate a lot, and it helps us do lots of things that we're going to be working with later in the course. The mutate function helps us add or modify columns. And its general format is going to look something like this. So we'll have the data object that we're either creating or updating and we're assigning to. Then we use the mutate function with the data that we're going to use, or we pipe the data into it, just like our other functions, comma, just like our other functions. And then this looks really similar to our rename function, but it's the new data that we're making equals the source. So let's look at that in an example. We're going to create a new column called new call, and it's going to be equal to the rate column. So we already have a rate column, and we're going to multiply it by 2. So let's take a look at our data just to start, so that we know what we're working with. So we have a rate column. We do not have a column called new column. We're making a new column here. We are adding this, updating our data set. So we're assigning it back here so that we're updating it. Otherwise, we're just going to show it on the screen, but we want to actually save it. So we're reassigning our object, and we're telling it what data to use. And this is the name of the new column. And the source for it is the rate column, and we're multiplying it by 2. When we take a look at our modified data set here, we see that we have created this new column by creating a double version of our rate. So here we have ×2 for Pueblo, Colorado. So let's see that over here. I'm going to preview a larger amount. Okay, so I can see that if the rate was 0 in my new column, I'm also going to get 0. This can also help us to add or modify columns. So we could use it. We used it to make a new one, but we can use it to also modify an existing column. So we saved what we did last time. And so we created the new column, but we can update the new column now so that we change it to be the existing column called new column divided by 2. And when we do that, we get back to our original rate value. So we've taken our existing column called new call, and we have divided it by 2. So in this case, we didn't make a new column. It already existed in our data. We updated ER30. So it exists here, but we changed it by dividing it by 2. So mutate can either add a new column, or if we name the same column twice, it's going to modify that column. Again, we can pipe data into our mutate function. So that's how that would look. We could take ER30 into mutate and do the same thing here. Now we're doing it yet again. We're dividing the new column by 2. And so now it is half the value of what it originally was. So the mutate function helps us add columns or modify existing columns. Sometimes we want to get rid of columns. We can do that with either the exclamation mark or the minus sign when we select. So we could say, I want to select ER30, but not the new column, and that's going to get rid of it. So I can do that here. Now I'm back to my original. That's just printed it here. If I want to save that result, I'm going to have to do something like this. And now if I look in my environment, I can see I'm back to 6 variables. So that's good. Maybe I want to even take a look at it just to check. Looks good. Got rid of that column. You can also just simply select the columns that you want to use. So I could list out all the other columns and that would get rid of the new column. That's hard though if we have a lot of column names. So this option is really helpful. You might see people sometimes assigning it to null, and that's an old base R way of using things, but this way I think is really easy to interpret. And the cool thing about this is we can easily do it for multiple columns. So we're going to use that combine function. This would get rid of the new column and the year column. And we just put that inside of our select function. That's the same as this. We've just put in our combine function another column name. Notice that the exclamation mark is at the front of our list in our vector that we combined together. We have questions about that before we move on? Yeah, so we just showed how to exclude more than one column. All right. And yeah, if you go scroll through the slides, you'll see the information about the set seed. The URL there, if you go through the part where it was for section 2, should have the correct URL. Okay, now we're going to talk about ordering columns and ordering rows. Also, as a reminder, we're going to be practicing all of these things in our labs, so don't worry about that. So we may have noticed that when we use the select function and we put our variable names in a particular order, it does the output in that order. So for example, here we have year all the way at the back, but we've selected year to be first here, then rate, then county, even though county is the first one here. So the way in which we select will impact the output here. So that creates the order of year, rate, county. Okay, so I'm going to do a different option. I'm going to put rate third and see how that looks different. All right, so here rate is third, and here rate is in the middle. And that's because we did rate in the middle here in our selection, and we did rate last in our selection here. There's also a tidy helper function called everything, and we can use that to help us arrange our columns. So say we wanted the new column that we made to be first. It's always by default going to be last. If we wanted it to be first, we could select for the new column to come before everything. So we're selecting from the ER data set and we're doing new column before everything. So we could instead pipe this in, let's say, let's select, I'm going to do rate before everything. And I'm going to print out ER30 so we can see it first. All right, so here's our original data. Rate is the second variable. I have moved it to the front here when I put everything else behind it. Sometimes we need to do fancier relocations, and we can use the relocate function to do that. So we don't have to use select for this. We just directly use relocate. And it's got these arguments that have periods before them, which is a bit unusual, but they're really helpful. One is dot before and one is dot after. And they specify the column where we want to place this. So for example, looking at our data set here, let's say we want year to be moved to before rate. We want it in between county and rate. So we could say relocate, use the ER30 data, and put year before rate. And that's going to put year right here before the rate variable. So let's try something else over here for some additional practice. I'm going to again show the pipe version of piping our data in. And here's our data set. Let's say we want to move visits to be right next to rate. And I'm going to use dot before rate. That should do the same thing that I want. All right. So that moved visits to be right before rate. If I do after, I'm going to put it after. Very useful function. All right. What about if we want to order rows? So we just saw how to order columns. What about ordering rows? This is super helpful. There's a function called arrange, and it automatically arranges in increasing order. So it starts with the smallest and then goes to largest. So this is helpful if I want to, see my data in a sensical manner. Like maybe I'm really interested in how things have changed over time, and I want to order by year, where it's starting at the lowest year and increasing. I could arrange my data ER30 by year, and it would look something like this. So my actual data, we'll get rid of our difference here. My actual data here, the year is just totally jumbled. It's totally random because I did a random sample here. But I don't like that. And again, I can pipe, I'm going to arrange by year. Much better, right? Now I have everything ordered according to year. Sometimes I want it in descending order, and so I can use the descending function to do that inside the arrange function. So if I do that, it's going to start with the largest year and go in reverse order. So let's add that to our function here. I'm going to say descend year. So this is the same thing. This just has it piped in, and this does not. And I'll get the same result of starting with the largest year. We can actually combine this in using different variables. So here I'm prioritizing arranging by rate, increasing rate first, and decreasing rate, decreasing year. Or if I put it in the opposite order, it's going to prioritize the year first and then the rate second. So the order in which you put it in is going to prioritize. But we just put a comma in between the different variables that we're arranging by. All right. Any questions before our gut check? All right. What function would be useful for changing a column to be a percentage instead of a ratio? We wanted to modify an existing column and change it from being a ratio into a percentage. Would we use filter, select, or mutate? Very good. Yes. We need to use mutate to create or modify existing variables, whereas filter is for filtering out rows and select is for selecting out columns. Another gut check here. How would we interpret ER30 then piped into filter year greater than 2020, piped into select year rate? Would we get the ER data, then filter it for rows with years over 2020, then select only the year and rate columns? Or would we get the ER30 data, then filter it for rows with year values of greater than 2020, and then select for rows that have values for year and rate? The difference here is what is select doing? That's right. So we can think of our pipe as sort of a then statement, and our select is going to select columns. All right. So in conclusion, select and filter can be combined together. We can do that in a few different ways. We can nest them inside one another. That can get pretty confusing. We can create intermediate objects, but that can be kind of annoying and we have to use a lot more code. Or we can do the best option, I think, which is our pipe, which makes it easy to think about sequential steps. We can use select and relocate to reorder our columns. Relocate has that dot before and dot after argument. We can use arrange to reorder our rows. We can do that in descending order or increasing order. Increasing is the default. We can remove rows with filter. That's what filter is for. And we can remove columns using select with an exclamation mark in front of the column names, or just not selecting it. Mutate is a super important function, and that's going to be for creating new variables or modifying existing variables. And it looks kind of like our rename function, where we've got our new variable and equals the source of what we're doing to it. You may see this, just a note, you may see this $ operator. It's really similar to poll. This is a base R way of doing things. We really recommend, though, that you try not to use it if you're using a lot of the tidyverse, which we will be, because it doesn't always play nice. So sometimes when we create a vector by pulling out the data using this option, it's not going to play nice with the tidyverse and the functions aren't going to work. So in case you see this when you're looking for help online and you start running into weird errors, that's what's happening. And people can also use that sort of in a mutate way. So here we're saying take the rate variable and divide it by 2.2. So that's modifying that variable. Well, actually, it's creating a new one here. So you might see that. But again, we really suggest that you focus on mutate because it's really powerful and it's going to help us do a lot of other things in the future. All right. Any questions before we go to lab 3? And that will be the rest of today. Yes.
Small.
You don't have to actually deploy our part of the tidyverse. So just the library tidyverse will be sufficient. Yeah, the only other thing we talked about was janitor. So if you wanted to use that one, you'd have to load that one too.
All right. So let's keep on going here and take a look at 3.1. So we're continuing to do some subsetting. We're creating a subset called CES Alameda from CES that contains the rows for Alameda and only these columns. So let's break it down step by step and kind of try to make it a little bit more piecewise. So if we are creating a new object, that's going to go on the left-hand side. Take CES Alameda. And I would say we should probably start with contains the rows for Alameda for the county. So if we take a look here, we're only looking for California County is Alameda. So give us a moment to do a little bit of that and see if we could get some code started. All right. So first thing we'll want to do is if we're subsetting the rows, we're going to want to use filter. And then on the inside, putting that data set. And we want to only have rows where the California County is equal to Alameda. So remember with rename, we only had one equal sign. Or when we're talking about arguments for functions, having that one equal sign. But because we're doing a kind of like a logical comparison, it's like greater than, less than, equal to, we want those two equal signs here. And because Alameda is not a column, we do need quotes. Okay, let's see if we can get that to work. All right, so we have 360 observations. So just a gut check here. If we had left off one of those equal signs, it's saying, hey, maybe you meant to use double equal signs. So that's a pretty helpful error message. If we forgot our quotes, it's saying object Alameda is not found. We don't have a column named that. We don't have a variable named that in our environment. So we filtered it, but we still want to only select a couple columns. So let's take it on to the next step. Let's do the same object again. We'll reassign it by doing select. So just pick out a few columns. This time we're using this object here into the next step. And then we want to pick the columns that we want. So we wanted traffic and asthma. And these do not need the quotes here. All right. So let's take a quick look and see, again, did that change take effect? Yeah. So looks like I still have those 360 observations from last time, but now I only have the two columns. Okay. And then the dimensions of this data set, let's just put a note to ourselves that it was 360 observations and two variables. So we're going to try to do the same thing with pipes instead. So we're just changing the grammar a little bit. We're reordering some things, but hopefully it's going to give us the same thing. And pipes are nice because they allow us to kind of chain things together. And we know that, data cleaning, data analysis involves lots of steps. And so the pipes help us chain those together in kind of a chronological way. And so I think they're really convenient for that reason. So let's get a little bit of practice playing around with that. So whenever I am thinking about using the pipes, I always want to start with the data. So instead of starting with the function or the new data set, just starting with the data. If we wanted to reassign it, same thing, that could go on the left-hand side. Okay, so data. Next step is going to be sending that along into the pipe and then telling it what you want it to do, right? So you sent the data through the pipe into the function. So filter. You still have to tell it what you want it to do, though. So we'll say the same thing we set up here, California County. And notice it's giving me a really nice preview there. I can just hit tab to select it or enter, and Alameda. Okay, so let's take a look at the difference between what's up here and what's down here. So I just took CES and I put it on the outside. It was right here, but I just snuck it over here and chained these together with a pipe. And if I wanted to keep going, it's pretty straightforward to just tack on another pipe, send that data into the next step. So again, we don't need to do the data because that's what's coming right here before the pipe. Sending the data into the next step, we can tell it a function. And again, traffic and ASMA. All right, let's see if that will work for us. All right, so just to prove it to ourselves, let's call it something else. And looks like it has the exact same dimensions. So I think that the filtering and the selecting is working the same. Any questions about the pipe and what we changed here? So what happens if you do the steps in a different order? Why does this not work? So let's just take CES. We'll try to select and so see what we get. We get those two columns. That's all we've got. And then if I want to filter, this is not working, right? So why is that not working? So this part of the data looks like this, right? It's just the two columns of the data. And if I want to take that into the next step, that filtering step, I no longer have that column, California County, CA County. I don't have it. So if I don't have that column, then I can't filter based on it. So order can be important because it's going to follow one pipe and then the next action and then the next action, right? It follows them in sequence. Okay, so you mean, let's see, we got to go up here, I think. Yeah, so make sure that reassignment step happens. This is rename, so we're not actually dropping any columns or anything like that. We're just renaming this one to be this. And I'll drop that in the chat just in case anybody else had that issue. Sometimes you miss a step and it's like, wait, what happened? Anything else kind of weird going on? And it usually is, just something happened out of order, maybe. Not that, your code is wrong or that you don't understand it. Sometimes it's just a matter of doing things in the order. All right. We're ready to keep going. Let me know. Give a thumbs up or say in the chat that you're doing good. All right. Looks like a couple of you didn't see a thumbs up or anything going on. What's happening? Okay. Looks like we got it. Sometimes it just takes a second. All right. Well, if there's anything we can help with, just feel free to drop any questions in the chat or come off if you've got a question. Happy to help. All right. So let's do a little bit of sorting. Always good to kind of see our data arranged. If you want to be sneaky like me and just go over to the data and sort it by clicking on it, you can do a little bit of that. But sometimes it's we want it actually sorted in the data itself. So let's arrange some data here. So let's take CES Alameda. And we're actually going to reassign it. We're going to take that old data and arrange it. And we can take the data and we can arrange it by traffic, value, and increasing order. So it's going to go increasing by default. And just to give ourselves a look here, taking a look at traffic, it looks like it's in increasing order. So that's good. Always good to double check the data that it arranged it how you wanted it to. Could have also done the pipe and arrange. And so the data actually goes on the outside if we use the pipe, and could try that kind of grammar if we prefer. I love the pipe, so I prefer this one down here. All right, and then finally we're going to create a new variable called ASMA 100, which is equal to asthma divided by 100. So, maybe we have a percent and we want to take it into a proportion. We might maybe be interested in that. So let's take the data and we're going to use mutate to create a new column. Okay, we're going to replace the old data using the reassignment. And whenever we're kind of starting to create a new column, select, filter, we're always going to start with the data. And then let's throw that into the pipe. We're going to take it on to the next step. After that pipe is going to be the function that we use. So here we're going to do mutate. And then just like with rename, we want the new stuff on the left and the old stuff on the right. And same with the structure of the assignment arrow. So new stuff is over here. Old stuff is over here. I'm going to create a column called asthma 100. We got to tell it what we want the values to be. So we want those values to be the asthma column divided by each value divided by 100. Let's see what that looks like. And so just taking a peek over here, I have two variables right now. And so if I'm making a new column, I should now, should have three once I run this. All right. So it looks like a third column. Let's check it out. All right. So if I take a look at these, so this one is 12.01 is now 0.1201. You can see I kind of moved the decimal place over on all of these. So yeah, that can be useful if you ever needing to make a transformation or even add two columns together. Maybe you have a column for each day of the week and you want a weekly total. Be able to add those together and make a new column using mutate. All right. Questions about, we covered select, we covered filter, we covered mutate, arrange, a bunch of really useful functions, but there's quite a lot of them. So what questions do we have on the functions and kind of methods we covered today? Absolutely. All right. We're just about at time. Any final questions before we wrap up for today? Yeah. So the output is going to depend on the data set you give it. So here I gave it the CES Alameda data. So if I had given it CES, I would get something else, right? So if I did this, I get that whole data set. Still did the arrangement, right? But I can't even see the traffic column here. Yeah. So it really just depends on what you put into the pipe.